Okay, so what is a derivative? Just to start with, let's look at what an actual derivative is and a few of the basics. Now, what a derivative does, it gives us the gradient of the tangent. So down here, it would give us, there's the tangent if it touches once, and the derivative is going to give us the gradient of the tangent. So that's a positive derivative or a positive gradient. Here, what the nice thing about that is the gradient of that tangent is going to be 0. The gradient of the tangent down here is going to be 0, which is going to be very, very useful later on. The gradient of the tangent here, well, it's going to be a negative, and that is exactly what the derivative gives us. The derivative gives us the value of the tangent or the gradient of the tangent at any point. So the basic rules, and we can go through first principles and all the rest of it, but the basic rules, if we want y prime of this, we just bring the power down. 3 times 6 is 18, x squared. So we bring the power down and times it, and then we always take 1 from the power. So here we could look at this as 4x to the power of 1. So it's going to be 1 times 4 is 4, x to the power of 0. And what's x to the power of 0? Well, that's just 1. The 10, any constant like that, just becomes 0. So that is the derivative. If we have this, and the terminology might change, or the notation, this is f prime or f dash. Exactly the same thing. Y dash, f dash, y prime, f prime all mean exactly the same thing. What is it in this case? There's a power of 3 or cubed. 3 times 10 is 30. X, 1 less than 3 is 2. Minus 2 times 3 is 6. X to the power of 1. Okay. And this last one, we've got a fraction here, y equals 4 over x cubed. We don't know what the rule is when there is in fractions like this. So let's rewrite it up the top. So it becomes 4x to the power of minus 3. Now, we haven't found the derivative yet. All we've done is written y as something else. Now we're going to find the derivative. We're going to find dy dx. We bring the power down. 4 times minus 3 is minus 12. X, and you've just got to be a bit careful here. 1 less than minus 3 is minus 4. Okay, so they're the basic rules. That's the very basic rule, and we'll go on to product rule, quotient rule in the next video. So at this stage, one of the questions that you should be able to do, or could be able to do, is find the equation of the tangent to y equals 2x cubed minus 3x at x equals 1. There's a few things we need to know for this, and the main one is we need to know that any equation of the straight line is y minus y1 equals m outside of x minus x1. So this is like the point gradient formula. If we've got a point, x1 and y1, and we know the gradient, which we're going to get from the derivative, we can find the equation of this line. So at the moment, we know what x1 is. So we know what y is. We don't know what y1 is yet. We don't know what m is. We know what x is. And we know what x1 is because we know it's all happening at 1. So x1 is 1. So what's the first thing we might do? Well, we need to know what y is. So when x equals 1, at x equals 1, what does y equal? It becomes 2 times 1 cubed minus 3 times 1. Which equals minus 1. This is 1. 2 times 1 is 2. Minus 3 is minus 1. So we know that this is minus 1. Now what we have to do is find the m, the gradient. Okay, this is our point. This is our x1, y1. We want to find our gradient. What gives us the gradient? Dy dx, or the derivative. So we go back to our equation. Y equals 2x cubed minus 3x. What is the derivative? 3 times 2 is 6. X squared, take the power down by 1, minus 3. This is the equation of the tangent the equation of the gradient of the tangent at any point. We don't care about any point. We want to know it at x equals 1. So again, at x equals 1, what does m equal? 6 times 1 squared minus 3, which is just 3. So now we can put that in. And that is the equation of the tangent. We can make it a bit nicer. Y plus 1 equals 3x minus 3. Just expanding the brackets. And then taking the plus 1 over, we've got y equals 3x minus 4. And that's the equation of the tangent. If this was at x equals 2, what would change? Well, this would be 2. So this would suddenly become 2. We'd have to have a different y1. So that would be 2 and 2. So 2 cubed is 8. So that's 16 minus 6. So this would be 10 plus 10. So this would be plus 10. Mucking around a bit there. And if this was 10, it'd be 600 minus 3, so 597. So if we looked, this would be 597. So again, we could substitute into exactly the same formula. It's going to be y minus 10, y minus y1, 10, equals m, which was the 597 outside of x minus 2. And again, you could muck around with that, but I won't. Okay, hope that makes things clearer. Thanks.
Why won't you muck around with that, honey?
Because we don't need to. They should have done. Oh.